Finding range is helpful, but because of the way outliers affect my data, and it's not talking about where most of my data is, it's not super useful for telling us how spread out the data is between the minimum and the maximum. How do we find the average distance of the values from the mean? That is what standard deviation is. That's what we're going to be finding. This is the average distance of a typical data point from where the mean is located. All right, so I want us to take these 6 values. Does not matter what order you put them down in, 14, 14, 15, 18, 20, and 33. And we are going to put those in this value column here. All right, 14, 14, 15. 18, 20, 33. All right. Distance from the mean. How are we going to figure out how far away from the mean we are? First of all, what was our mean on this? 19, or 19 for that. Median was 16.5, right? Let me go back and look. I know we wrote this down. Yes. Our mean was 19 colleges. Our median was 16.5. All right, so distance from the mean. We're going to take our data value and we're going to subtract the mean. So when I do that, I get -5, -5, -4, -1, +1, and what is that, 24? No, 14. 14. We're going to take those distances, the -5, -5, -4, -1, 1, and 14. We're going to square them now. The reason that we're squaring them is so that we're creating positive values. I want to know the average distance. Distance can never be negative. We don't have -5 miles. So we're taking our values and we're going to make them be positive. So -5 squared. Please go ahead and do this for all of these values, and then that distance from the mean squared, I want you to add those up. So you're going to add the 6 squared distances. Does anybody have a total for me? 25, 25, 16, 1, 1, and 196. 264. And what would I do to that 264 if I am trying to find the average? Divided by 6. So I'm going to do 264 divided by 6. What'd you say? 44. All right. So before we push forward into anything, I wish I had room to write above, but distance from mean, what I want you guys to have here is that this should be xi minus x bar. I would write it above here. Value, each of those is an xi. So distance from mean squared, I have xi minus x bar squared. This is the standard notation that gets used for this. All right. So that squared, or the average that we just found, is the squared distances from the mean. How do we use this to find the average distance from the mean? What did we do to each of those values? Squared them. So what do you think I need to do at the end? Square root. So my standard deviation, I'm going to do the square root of 44. And I got about 6.63. Yes? So that's a great question. The first part to answer your question is this, and probably 2 more times, is the only time I will ask you to calculate standard deviation by hand. So this isn't going to come up a lot where you have to worry about that. Technically speaking, first thing you do is find the distance away from the mean, and that distance should be indicating whether I am to the left or to the right. So you would want to see the negatives and positives if you have to do it out by hand, but there is absolutely no way you will calculate this by hand on the AP exam. They will not have you do it. We're calculating it out by hand right now because I want you guys to understand how it's being found, and then understanding how we're arriving at this helps us understand what it's meaning. So what is standard deviation telling us? Well, first we found how far away from the mean is it. We squared it to make it positive. We found the average of all of those different squared distances, and then we took the square root. So what we're saying here is that a typical group, when they add up all the colleges that they're planning to apply to, a typical group is going to be plus or minus 6.5 colleges from where our mean of 19 is. So this is the kind of variability that we can expect. Here is the formula for calculating standard deviation. We usually use SD to abbreviate standard deviation. It is equal to the square root. This does need to be tall because we're going to stick a fraction in here. Square root of that sigma, sideways m sigma, which means we're going to add up all of the xi minus x bar squared values. My denominator. What did we divide by when you guys were finding that standard deviation for me? We divided by n. When we have every member of the population, we can divide by n. Do you guys, is this all AP statistics students, period? Is this even all AP statistics students at Pike High School? So you guys would be considered a sample from the larger population. When we're working with a sample, we're going to end up with some sampling error. And the way we account for that is with what we divide by. We divide by n minus 1. If I divide by a smaller number, what happens to my result? If I took that 44 and I divided it by 5 instead of by 6, it's going to be bigger. It's going to show me more variability. When I'm looking at a sample, I'm going to assume generously that the actual population has more variability than what my smaller group does. And this is how I account for that variability. All right. Number 5. Enter classroom data, find the summary statistics. We're not going to go to Staplets. Staplets, great. I want you guys to pull out your graphing calculators. I'm going to show you how to get these summary statistics from your graphing calculators. So here's my level graphing calculator. This should be showing what is up on your screen. All right. Summary statistics. Do you guys see where it says stat right here by the arrow keys? Hit that. That's where almost everything for this class is going to be located. You're going to hit edit, so option number 1 there. We have all these different lists. We're going to enter all of our data here into list 1. So we're going to put every group's response, 14, 14, 15, 18, 20, and 33. One thing I want to caution you about, when you enter that very last data value, you have to hit enter or else it won't put it on the list. Make sure you hit enter after the last one. Stat, option number 1 for edit, and then you can enter those values in there. So stat, edit, enter your values. Yes. There's a bunch of values really far down. Okay, so I want you to scroll up until it highlights L1. Oh my goodness. Yeah. Okay. Now hit clear and hit enter. Now you can enter your data. You guys okay with getting the data put into that first list? Nope? Okay, yes. Yep. So you're going to type the number in and then hit enter. Yep. Hit enter after each of your data values. All right. I just want to make sure everybody's got their data entered first, and then we're going to go from there. Everybody have their 6 pieces of data in, or very close to having them in. Okay. Once you have your data values in, I want you to hit stat again. We want it to give us summary statistics, which means it's going to have to calculate things. After you get your data in there, you hit stat, so you see this menu, arrow over to calc. How many variables did we have? How many questions was each group asked? Just 1. We have 1 variable stats. Hit enter. If it shows you this screen, not everybody's does, if it shows you this screen, just hit enter until it calculates. Make sure that it says list 1, L1, because that's where your data is. If yours says anything different, I'll show you how to change it. Calculate. There's our X bar. What did I say X bar stands for? Mean. X bar is the mean. Look at this right here. That's sigma x, 6.63. Isn't that what we found when we did our square root of 44? Go back to your page. Grab a cell phone calculator for me. I don't want you to do anything with the graphing calculators because I want to leave this up on the screen. Cell phone calculator is fine. Take 44 and divide it by 5. And then square root that number. Yep. Oh wait, sorry, not 44. The way we got 44 was by dividing by 6, right? Yeah. Sorry, let me back up. What was the sum of everything? 264. Take 264 and divide that by 5. 264 divided by 5. Then square that number. Square root that number. 52.8. Right there. So here's what these things mean. This little guy that looks like an O with a tail off to the side, that's a lowercase sigma. This right here stands for the standard deviation of my whole population. So if you guys were the whole population that we were looking at, the standard deviation would be this one. SX stands for the standard deviation of my sample. And so this is the one where we're dividing by n minus 1 before we square root, 7.266. It tells me my n value. And this is going to come in real handy as we get into the next couple lessons, but scroll down for me. Tells me my minimum, tells me my first quartile, tells me my median, 16.5, my third quartile, and my maximum.
Can you show us how we got to that?
Can I show you what? How we got to that? Yep, stat. Then you arrow over to calc because you wanted to do calculations for you. And we chose option number 1 for one variable stats. And then enter, yes.
Oh, that's what you mean.
Yep. We'll go over that. You'll use this so much that by the time you get to the AP exam, there will be no questions about how to get there. All right. Monday, we're going to do the back side of this. And then we're going to do our very last lesson piece, which should go reasonably quickly. Tuesday, we will start reviewing for tests. I'll give you your test review on Monday so you guys have it and can start working on it. Tuesday, we'll spend some in-class time reviewing. I've got a couple different activities to help us practice that. Wednesday, we're going to do a free response question practice. I'm going to pull an AP exam question. I think I'm going to pull it from last year's exam. And we're going to do that in groups, and then we're going to compare those answers, your answers, to the sample student responses. What got a 4, what got a 3, what got a 2. Thursday, we still have another review day. First test will be Friday, so we'll leave them today. Homework is due on Tuesday. Same here. That's my geometry testing on. I tried so hard to get my tests on different days so that I'm not walking home with this many tests over the weekend next weekend, but that is not to be. Have a good one, guys. I'll see you on Monday.